Hello. In this video, we'll be going over the USACO 2019 US Open Contest Bronze Level Question Problem 2, Milk Factory. This is the question that we'll be going through. You may pause and have a quick read. Okay, let's go ahead and start with this. So to summarize the basic idea, you have Farmer John who has a milk factory that has N stations and N minus one walkways. So the key here is that there are N minus one, or well, N stations and N minus one walkways. That'll be important later on. He converts those walkways into conveyor belts that go one way. So initially it was both ways, but now it's one way. What you're trying to do is find if there is a path, or if there is such a station that you can get from one station to or from any station to that station. So starting from any station, you have some path going to some other ending station. The key insight here is that, the format that you're given the problem in is you have N stations, or the number N, which is the number of processing stations, and then the next N minus one lines that come afterwards. Those are the A and B, so A being the start position, and then B being the ending position. Going from, so A does not equal B means that there's no self, so that you can't just go to itself. And the basic idea is that you're able to travel from one direction to the other. Now in this case, what the output, or what they're looking for in the problem is that given this input, you want to get an output of 2 because you can get to 2 from 1, so 1 to 2, and then same 3 to 2, you can get to 2. So 2 is considered the point that anyone can access. Okay, before we get into the code, let's quickly work through a quick diagram or sketch of the problem. Okay, so the basic idea is we have this number n, which is some number, and that's defining the number of processing stations that are there. So these are, we'll call S or stations. And then we have walkways, which is n minus 1. So the key insight here, something you may find useful, is the idea of trees, and more specifically spanning trees. So the idea of a tree is, the basic property is that they are some way of connecting objects to one another using these paths. The key things that trees have are that if there is a root, like I guess there's some root node that everyone starts with, is kind of what we're trying to find. And the connections, they're basically one way. So in this case, you can pretend like you start here and you can go from there to there, or there to there. More so, actually, we're trying to look for something that goes this way. The key thing for the n minus 1 is that it's going to be a spanning tree. So what that means is that no matter how long the root is, you'll only have n minus 1 paths. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So this has 5 stations, 4 paths. And this guarantees that there are no cycles, because if there was a cycle, so let's say there was a cycle this way, that'd be 1, 2, 3, 4 for 1, 2, 3, 4 stations. And no matter how many times you add, so maybe if you only do something like this, you'll still always be equal number of paths to stations. So that guarantees no cycles. And yeah, so from there, what we can gather is that what we're trying to look for is there such a station that it doesn't connect to anyone else? So in this case, if we had something like this, and this is numbered 1, 2, 3 from the diagram, or from the sample problem, the 1 goes to 2 and 3 goes to 2. And so 2 is considered anyone can reach. So this is our solution there. Sometimes there's not a solution, so maybe, sometimes it might be something like this, where you have 2 options. The thing in the question, though, is specifically looking for a single solution. So if you have 2 solutions that work, so 1 and 3 would be solutions, then you would return -1, since there's multiple solutions. And if there does seem to be a way, so for example, I'm going to violate this rule, but for the sake of argument, let's pretend there is one that goes this way. pretending if there was a cycle, or if a solution doesn't exist, then you'll have some way of going from one edge to the other. And so you can do -1. This case is, you don't need to worry about this case. So the only thing that we'll need to worry about is the uniqueness stance. Because given that the walkways already, it is spanning, it spans everyone, we can at least guarantee that regardless of how it goes, there should be one way to get to, from one to the other. We just have to worry about it not being unique. Okay, so let's go ahead and look at the code. Now moving on to the solution. So the way I formatted the solution was I created this outgoing dictionary and decomposed the args. So the idea of the outgoing dictionary is that I'm trying to keep track of all the nodes, whether they're outgoing or incoming, or rather in this case, just outgoing. The reason why we're looking for that is, so to find the outgoing, all you have to do is find the walkway, the value at the current walkway at 0. If that's currently in outgoing, then we add 1 to it. And if it's not 1, then, or if it's not found, then we let that equal 1. So basically, we're just trying to count how many times it flows out. We set the answer to -1. And the reason why we want to find all the outgoing ones are specifically to look for the ones that have no outgoing edge. The reason why is because if something has an outgoing edge, then that means that you can follow a path to get to another area. And then you keep going until you find something that can't go anywhere. And that solution is if you can't go anywhere, that's kind of our solution. We just have to make sure that we don't find multiple of them. So that's where this comes in. So go through the whole 1 through n. Check I if it's inside outgoing, or rather if it's not in outgoing. Check is it equal, so does it, or rather if answer is equal to 1 or -1 in this case, then that means it hasn't been set yet. So the answer hasn't been set. So I set the answer to the I value. And if it already has been set, so it's not -1, that means we have found 2 or more solutions that have no outgoing edge. So basically you can follow one path to get to one area, but to get to a separate area, you have to follow a different path. So that's why we can't allow that. And then we return the string version of the answer and then write that to file. So that is one solution to the problem. For this one specifically, it runs in O of n time, since we just do an iteration through the range n-1, and then a similar iteration through n-1. So it should take you basically linear time to solve this. And the key thing here is we don't have to check we don't have to check every single point. We just have to check all of them once, and then we know. That'll be all for this problem. Thank you for watching.